Now we see the note. Similarly, we can write A is equal to A into I and apply a sequence of column operations on A is equal to AI till we get I is equal to A into B. Then B is called the inverse of the matrix A here. Now, after applying elementary row operations or on A is equal to I into A or column operations on A is equal to A into I, suppose we get one or more zero rows. Here, while transforming the rows in elementary row operations or elementary column operations, if we are getting any one row completely zero elements or more rows also completely zero element, or even in column also if we get all the elements in the column are zero or one or more column having zero elements, then there we immediately conclude that the inverse of the matrix does not exist. Now we can see the problem related to elementary row operations, that is the inverse of a matrix by elementary row operations. The question 1 is find the inverse of a matrix 1, 3, 5, 7 by elementary row operations. The procedure is, first we write the given matrix as, or if it is not mentioned as A, B or C, but we can take here A only. A matrix A is given 1, 3, 5, 7. Now we write A is equal to I into A. That is, the matrix A is given as 1, 3, 5, 7 is equal to identity matrix corresponding to the given matrix of the same order. Here this matrix having order 2 cross 2. Therefore, the same respective identity matrix we also select here. That is 2 cross 2 order second order identity matrix 1, 0, 0, 1 into A. We need not write A again here. We can write just A because A is already written here. Now apply elementary row operations successively till this matrix converted into the identity matrix as 1, 0, 0, 1. Now apply R2 minus 5 into R1. That is, first multiply the first row elements 1 and 3 by 5, then subtract it from the second row and write the answers in the second row. That is, 5 into R1 is 5 and 5 into 3 is 15. Now the first row remaining as the same, that is 1, 3 only. Therefore here we have this matrix 5 into 1 is 5 and 5 into 3 is 15, but we write the answer in the second row. The first row remaining same as 1, 3, then it is row 2 minus 5 row 5 into row 1, that is R2 minus 5 R1. 5 minus 5 is 0 here and 7 minus 15 is minus 8. Similarly, the same operation we should apply to the right hand side also. Here also 5 into 1 is 5 and 5 into 0 is 0, then row 2 minus the first row remaining same 1, 0. This will be 0 minus 5 is minus 5 and 1 minus 0 is 1 into A. Now our intention is to convert the first matrix, this matrix A, left hand side into the identity matrix 1, 0, 0, 1. Therefore we make non-diagonal elements as 0 and the diagonal elements are equal to 1 or unity. That is, now we multiply the second row by minus 1 by 8 here. So this we want here the element is equal to 1. Therefore to get 1 we have to multiply by minus 1 by 8. So therefore we have minus 1 by 8 into row 2. The first row remaining same as 1, 3, 0 into minus 1 by 8 is 0 and minus 8 into minus 1 by 8, minus into minus plus 8 into 1 by 8 is 1. The right hand side is 1, 0. The first row remaining same, then row 2 minus 5 R1, that is 5 minus 5 minus minus 5 into minus 1 by 8 is 5 by 8 and here minus 1 into minus 1 by 8 is minus 1 by 8 into A. Now we apply here row 1 minus 3R2, so that we are getting here one left hand side the identity given matrix A is completely converted into the identity matrix 1 0 0 1, that is equal to 1 minus 15 by 8, 0 plus 3 by 8, 5 by 8 and minus 1 by 8. Here we write the answer in the first row, because beginning we have written R1 minus 3 times R2, that is 3 into every element of the row 2. So that we getting is equal to minus 7 by 8. Here 8 minus 15 is minus 7 by 8, 0 plus 3 by 8 is 3 by 8 and 5 by 8 and minus 1 by 8 into A. Hence here we got left hand side is equal to identity matrix as I is equal to this matrix is B into A, then the matrix minus 7 by 8, 3 by 8, 5 by 8 and minus 1 by 8 is the inverse of the given matrix A. Hence we write A inverse is equal to minus 7 by 8, 3 by 8, 5 by 8 and minus 1 by 8. Next problem, question number 2. Find the inverse of a matrix. Now we considered a third order matrix, a matrix containing 3 rows and the 3 columns, that is 2 1 3 5 3 1 and 3 2 3 by elementary row operation. Here the procedure is same, right? The given matrix A is equal to I into A. A is 2 1 3 5 3 1 3 2 3. Now we convert this matrix into the identity matrix and this into the inverse matrix. Here I is 1 0 1, third order identity matrix 1 0 1 0 1 0 0 0 1 into A. Now here series row operations, that is R1 and R2, we are adding R1 and R2, then we subtract it from the after multiplying the row 3 elements by 2, but we write the answer in the first row, so that we get 1. We write the answer here, second row and third row remaining as it is, 5 3 1, 5 here same, and 3 2 3 3 2 3 same, only row 1 changes after all these operations. That is here 2 plus 5 is 7, 7 minus 2 into 3 is 6, 7 minus 6, that is equal to 1 here. Next here R1 plus R2, 1 plus 3 is 4 minus 4 here, that is 4 minus 4 is 0. Similarly 3 plus 1 is 4, 4 minus 6 is minus 2. Similarly the right hand side, the row 2 and row 3 remaining as it is, only row 1 changes after adding R1 and R2 minus 2 into R3, that is 1 plus 0 is 0, 0 minus 2 into 0 is again 0, that is 1 only. Now 0 plus 1 is 1, 1 minus 2 into 0 is 0, that is 1 only again, 0 plus 0 is 0 minus 2, that is equal to minus 2 into A. Now R2 minus 5 R1, after multiplying the row 1 elements by 5, then subtract from the row 2, so row 2 changes. So in R3 minus 3 R1, now multiply the row 1 element by 3, then subtract it from the row 3. Therefore here R2 and here R2, row 2 and row 3 getting changed, and row 1 is remaining as it is, 1 0 minus 2, row 2 minus 5 R1. So here 5 minus 5 into 1, this operation we see 5 minus 5 is 0, then 3 minus 5 into 0 is 3 only, then 1 minus 5 into minus 2 is 10, so the plus 10, the 1 plus 10 is 11, then row 3 minus 3 R1, 3 minus 3 into 1, that is 0, next 2 minus 3 into 0, that is 2 only, and then 3 minus 3 into minus 6, that will be 9 we will get. So similarly the right hand side, that is 1 1 minus 2 minus 5 minus 4 10 and minus 3 7 into A. Now apply again R2 minus R3, row 2 minus row 3. So we get 1 0 minus 2, 0 1 2 and 0 2 9 is equal to 1 1 minus 2 minus 2 1 3 and minus 3 7 into A. Again apply here until we get the left hand side matrix as a identity matrix. We continuously or successively apply the row operations. R3 minus 2 R2. Now row 3 changes after row 2 multiplied by the element non-zero element 2, then we subtract it from row 3. Hence row 1 and row 2 remaining same, that is 1 0 minus 2 0 1 2 remaining same, only row 3 gets changes. So here row 3 minus 2 into R2, 0 minus 2 into 0 is 0 it is, and 2 minus 2 into 2, that is also 0 here, and 9 minus 2 into 2, that is 4, 9 minus 4 is equal to 5, and here it is first row remaining same, 1 1 minus 2, second row also same, minus 2 minus 1 3, and the third row minus 2 into R1, minus 3 minus 2 into minus 2, that will be 1 we will get, and that is 4 here, minus 3 plus 4 is 1, and minus 3 minus of 2 into minus 1, that is minus 3 plus 2 is minus 1, and 7 minus 2 3 is a 6, that is 1. Now here 5 is there, if we eliminate this 5, then the diagonal elements we get equal to 1, therefore we multiply by 1 by 5 to the third row, so that we will get 1 0 minus 2 0 1 2 0 0 1, this will be 1 1 minus 2 minus 2 minus 1 3, and 1 by 5 minus 1 by 5 1 by 5. Now again here row 1 is added to 2 times the row 3 elements, and row 2 minus 2 times the row 3 elements, so that we get here completely the identity matrix as 0 1 0 0 0 1 0 0 0 1 is equal to, here row 1 plus 2 are 3, 1 plus 2 into 1 by 5, that is 2 by 5, 1 plus 2 by 5 here. Next 1 minus 2 into 1 by 5, 1 minus 2 by 5, minus 2 plus 2 into 1 by 5, minus 2 plus 2 by 5, and here the second row minus 2 times R3, that is here second row minus 2 minus 2 into 2 by 5, and minus 1 minus 2 into minus 1 by 5, that is plus 2 by 5, and 3 minus 2 into 1 by 5, and the third row remaining as it is. After simplifying this, we get 7 by 5, 3 by 5, minus 8 by 5, minus 12 by 5, minus 3 by 5, 13 by 5, 1 by 5, minus 1 by 5, and 1 by 5 into A. Here this matrix is the inverse matrix. It is the A inverse.